Gravity as geometric residue, torsion from hadronic spin microstructure in an evolving spatial carrier. This work explores the possibility that gravity may arise as a coarse-grained geometric residue of a torsion sector sourced by the spin microstructure of hadronic matter. This proposal explores a candidate mechanism for weak universal attraction within a non-minimal Einstein-Cartan framework, defined on a primary three-dimensional spatial carrier. In this formulation, the carrier admits curvature, connection, and torsion as genuine geometric degrees of freedom. Within such a geometric setting, torsion may act as an independent sector capable of retaining structural residue in the carrier. Geometry evolves through an update operator acting on the carrier, while time functions only as an ordering parameter and carries no independent state. Because time therefore cannot store information or retain structural memory, persistence must instead appear as geometric residue encoded in the spatial carrier itself. The central idea is that the microscopic source of a torsion sector may lie not in electromagnetic structure, atomic magnetism, or bulk atomic spin, but at a deeper level of matter organization. Below the scale of electronic and chemical structure, baryonic matter possesses an internal quark-gluon spin microstructure associated with the fermionic degrees of freedom of hadronic matter. This internal spin configuration may act as a universal microscopic source for torsion on the carrier. Because this level of structure precedes electromagnetic ordering and atomic scale organization, the resulting torsion sourcing would not track electric charge, atomic magnetic moments, or material-specific electronic configuration. This move is partly motivated by the enormous strength difference between the known forces. The electromagnetic interaction between two electrons is roughly 10 to the power of 36 times stronger than their gravitational attraction. If gravitational behavior arises not from a primary interaction comparable to electromagnetism, but from a deeply suppressed geometric residue sourced at the level of hadronic spin microstructure, then its macroscopic weakness becomes less surprising. In such a picture, the effective interaction would emerge only after the coarse graining of many microscopic torsion contributions, whose detailed structure largely cancels. The resulting field therefore represents a small surviving geometric remainder, rather than the direct expression of the underlying microphysical dynamics. In a non-minimal Einstein-Cartan regime, torsion is treated as an independent state-bearing geometric sector of the carrier, rather than merely an auxiliary correction to curvature. In this setting, torsion represents an additional geometric degree of freedom of the carrier itself, providing the geometric channel through which microscopic spin structure can influence the evolving spatial manifold. Torsion contributions sourced by the quark-gluon spin microstructure of hadronic matter accumulate across many microscopic configurations, but under coarse graining, much of the detailed directional structure is suppressed. Because the underlying microscopic spin orientations are widely distributed and effectively random at large scales, the surviving field encodes only a small invariant remainder of the original torsion structure. What persists in the connection, torsion, and holonomy of the carrier can therefore appear as a nearly isotropic scalar torsion residue on the three-manifold. If such torsion residue persists across scales, its macroscopic behavior may admit a Gauss-Law-Like flux relation on the three-manifold. In this limit, the coarse-grained torsion field can be described by a nearly isotropic scalar potential whose flux through closed surfaces is proportional to the enclosed matter content. Under these conditions, the resulting field naturally produces an effective inverse square attraction, resembling gravitational dynamics while remaining largely insensitive to charge distribution or chemical composition. Within galactic systems, the resulting torsion environment would be sourced by the distributed baryonic matter of the galaxy itself, rather than being controlled solely by the central supermassive black hole. Each region of matter contributes microscopic torsion sourcing through its hadronic spin microstructure, and the coarse-grained residue accumulates across the system. The central black hole may still act as a strong local organizer within this environment, but the large-scale coherence of galactic motion would arise primarily from the collective torsion residue generated by baryonic matter throughout the galaxy. This perspective naturally includes extended baryonic components such as the galactic halo. In the case of the Milky Way, Baryonic matter distributed through the halo and circumgalactic medium would contribute to the same underlying torsion sourcing, reinforcing the distributed character of the resulting torsion environment. The proposal, therefore, does not interpret gravity as diluted electromagnetism. Instead, it considers the possibility that a torsion sector sourced by the spin microstructure of hadronic matter leaves a highly suppressed geometric residue on the evolving spatial carrier. Within a non-minimal Einstein-Cartan framework, torsion may contribute to the connection in a way that permits persistent holonomy structure on the 3-manifold. Under coarse-graining, the holonomy associated with this residue produces an approximately universal macroscopic attraction, consistent with the large-scale behavior normally attributed to gravity, allowing gravity to be interpreted as a geometric residue of this torsion sector.